Hello, today I'm going to show you how to balance CH3 plus O2 yield symbol CO2 plus H2O. To start, let's write it down. I already wrote the equation to save myself some time. Next, I'll put a line through the yield sign or symbol so I may separate the products and reactants to show the atom inventory for both sides. This right here is the inventory. So right now we have one carbon over here, one over there, 4, and 3 over here, 2, and 3 over here as well. Then I'm going to try to balance what looks like the most complicated formula, which is CH3OH. But before we get started, let's identify what the numbers are in the equation. The tiny numbers are called subscripts. See, they are the atoms inside a molecule, in which this case inside this O, well, not really inside, but below it at least. Next, you then see big numbers, which represent the molecules in a reaction. They are called the coefficients. Coefficients are the only things we're able to change to balance in an equation. Because if we were to change the subscripts, these guys, we then have a different atom. The law of conservation of matter states that matter can't be destroyed or created. That's why we shouldn't change the subscripts. Because like O3, for example, would not be O2. They'd be completely different. So now I'll put 1 in front of CH3OH to remind ourselves that the number is now fixed. This right here is a coefficient. That's what they look like. Alright. We should have a equation look something like this, like right now. We have one carbon on the left, so now we'll want to have one carbon on the right. So I'll put 1 right here. We aren't able to balance oxygen because we have 2 oxygen-containing molecules without coefficients, like this singular oxygen atom within this molecule, and this one in H2O. So we have right now 4 hydrogens on the left, so we'll want to have 4 hydrogens on the right to keep it balanced. There are already 2 hydrogen atoms on the right, so we must put 2. Why do you want to do that? Well, if you were to multiply coefficients by a subscript, basic multiplication, you then would get 4. It's basically like if you were to add another H2O right here, you then would count 4 atoms. And then you also, don't forget the oxygen atom, have 2 oxygen atoms in total. So then you have yourself 4, and now you would have 4 here. Now we have fixed 4 oxygens on the right. Oh wait, the left side is only 3 oxygens. Let's start over by doubling all the coefficients. So this would be 2, this would be 4, this right here would be 2. Now we can balance oxygen by putting a 3 in front of O2. You then would get, well, okay, now you would get 2 carbons over here, 2 carbons there. You then would have 2 times 3, 6, and then now you have 2 hydrogen atoms there. So then 6 plus 2 would be 8. And then you'd have 2 oxygen, because of that. these ones without a subscript would have 1 there. It's invisible, but yeah. So then you'd have, okay, 2 oxygen plus 6, 3 times 2. So then you'd have 8. Okay, so now you have 4 there and 4 there. So then you have 8 oxygen atoms. Then you would have 8 hydrogen atoms. We now see that they're now balanced. The law of conservation, again, says that matter can't be destroyed or created. If one of them were to have 1 or less more than the other side, say like this one had 7 instead of 8, like this side, that would not fix or mean it would break the law of conservation of matter. So that's why we balance equations to make sure that on each side, the reactants, in the products over here are equal. So our balance equation would be to here, okay. So we have 2 here, coefficient, then we have 3, then we have 2, then we have 4. We have 2 molecules of CH3OH plus 3 molecules of oxygen molecules. Yield symbol, which is close to the equal sign in math, but not really. Then we two carbon dioxide molecules plus 4 water molecules, and that's our balanced equation.